Okay, so for your quiz that's coming up next Tuesday, remember we spent some time graphing. We named axis of symmetry, vertex, y-intercept, and zeros, both from a function, like from the equation, and from a graph. Then we transitioned into talking about these complex numbers because we had to think about the idea that there's no solutions if you never cross the x-axis, and what do we do with that? Because we have to have two solutions always by definition that you guys haven't seen yet. So that's where we introduced the imaginary unit I. And we can do a lot of things with i's. So we learned how to simplify radicals with an I, right? That was example 1 and example 2, actually, because then we multiplied square roots with I. We did example 3, which you guys were super quick with, where we were just solving for x, and we had an I involved. And then yesterday we started just talking about operations on I. So we talked about adding and subtracting. We talked about multiplying, which I think was a little trickier for you guys. And I do have more multiplying practice today, because today we have to talk about, we're not actually dividing, we're rationalizing. So I don't know why I put this definition here, but two complex numbers of the form a plus bi and a minus bi are called complex numbers. That's not even a good definition because it has complex numbers in the definition. I don't know why I wrote that. But we learned that yesterday. So the product of a complex conjugate is always a real number. So this word we might be unfamiliar with, but say a and b are the same number. So say a is 2 and b is 3. If this was 2 minus 3i and this was 2 plus 3i, those two are conjugates. They are opposites of each other, and that's how we are going to cancel out an I part in the denominator. So a radical expression is in simplest form if no radicands, meaning the square root, contain fractions and no radicals appear in the denominator of a fraction. Similarly, a complex number is in simplest form if no imaginary numbers appear in the denominator. You can use complex conjugates to simplify a fraction with a complex number in the denominator. This process is called rationalizing the denominator. So this all hinges on the idea that, remember, I squared is equal to -1, right? So if you multiply an I by another I term, good things happen. So example 6a, this is sort of like your base case, where there's not something being added or subtracted on the bottom, but you just have an I on the bottom. So in order to get that I on the bottom to go away, what you can do is you can multiply by I over I. So if you just have an I on the bottom with no plus or minus, you don't need to multiply by the coefficient in the I, because then you'd have to reduce. Just multiply by I and I, because what ends up happening then is that you have 2I over 3I squared. And what did we find happens yesterday when you have an I squared? What happens to the coefficient? Yeah, it changes sign. So in this case, it'll turn to negative. And the reason for that is because it's 2I over 3 times -1 if you do that substitution. And so you end up with 2I over -3. Remember, a lot of you got to the point where you could skip this like substitution step. Some of you still needed that step, and that's totally fine, whatever you're comfortable with. I feel like yesterday was a lot of don't lose the negative, because that's kind of what it turns into. So this is the most basic case. So if you just have a single term, like a pure imaginary part on the bottom, just to multiply by I over I. Here's the more complicated case. So if you have a 3 plus 2I here, can anyone tell me what the conjugate is going to be? Does anyone know what the conjugate's going to be? So you're going to take all the same numbers. So I'll give you a hint. You're going to have 3 and a 2I. But what's going to be in between them? The minus. So it was a plus. Now we're going to make it a minus. That's all that a conjugate is. You take everything that you see on the bottom, but instead of whatever this sign is, change the sign. So if this was a minus, you'd make it a plus. Yes? Okay. So here's where yesterday you had to practice foiling and all that stuff, whichever method. And I forgot about the box method, so I'm going to show you guys that too at some point. But this ends up being 5i times 3 minus 2i over, and then it'd be, I'm just going to add parentheses here so we don't just multiply one thing in here. But it's this whole bottom times that whole bottom. And I forgot, I showed you guys the FOIL method and the distribution method yesterday. I forgot about the box method, so I just want to like add a little space here. I'm going to show you the box method now. Remember the box method was where you take like this part, so you do the 3 plus 2i, and then you multiply it by this one, which was 3 minus 2i. Do you guys remember seeing this layout? Yeah, so then you can do the 3 times 3 is 9. 3 times positive 2i is 6i. 3 times negative 2i is negative 6i. And then negative 2i times positive 2i is negative 4i squared. So the reason you need to use the conjugate is because look what happens on your diagonal, your like terms. What happens here? They cancel out. And then you just have to remember that this is really 9 plus 4, right? Because it'd become a negative 4 times a negative 1. So back to this line here. I just wanted to remind you guys of the box method because totally viable method. We can also multiply in this 5i. So on top right now on our fraction, we have 15i minus 10i squared over, and then on the bottom we have 9 minus 4i squared. But we can go ahead and just get rid of the I squared, change the sign, get rid of the I squared, change the sign. So that really, and remember real part first, then imaginary part, this is a positive 10 plus 15i over, what's 9 plus 4? 13. Okay, we have just rationalized that crazy fraction. Quite the process, right? Almost makes you miss the square roots. Questions about this one? Kind of a mess. I'm going to do this one. I won't do the box method here so it doesn't break up our chain of thought. But so now we have 2 over 5 minus I. What is my conjugate here? What's my conjugate? 5 plus I. Good. And that's going to be the top and the bottom. So I have 2 times 5 plus I over, and just always throw parentheses around this part and this part. So it'd be 5 minus I over 5 plus I. If I multiply this out, that one just gets distributed in, so I have 10 plus 2I over, on the bottom, I'll do FOIL here, so it'll be first, outside, inside, last. So my first would be 5 times 5 is 25. Outside would be 5i, so positive 5i. Inside would be negative 5i. And then negative I squared. So really what you're going to find is if you're doing the FOIL method, you can do a cheat. These middles should always cancel out if you chose the correct conjugate. You could do a cheat and just multiply just your last, I'm sorry, just your inside, or your first, and just your last. So don't do the OI part. Don't do the outside, inside. Because those are going to cancel. This negative I squared, I have 10 plus 2I over 25, and then it'd be minus, and then it'd be a negative 1. What's minus negative 1? Positive 1. So really my final answer is 10 plus 2I over 26, which actually I could reduce. I think for the sake of simplicity, I would accept this, but
Can we reduce this?
Yeah.
Yeah. What could we divide everything by? 2. So this could reduce to 5 plus I over 13. That's probably the most technically correct answer. I think on a quiz I probably wouldn't care. Your Go Formative might care because I don't remember how I wrote it. But yeah, you can divide by 2, divide by 2, divide by 2 to get that simplified answer.
Does the process make sense? Do we see where we're definitely going to lose some negatives? Probably. Lots of foiling today, or distribution method, or box method, whatever you want.
So you do have a homework assignment. Let me stop.